Hello there, welcome to a new video from 𝘄𝗄𝗄. Imagine getting inside a car and telling the car where you want to go. The car will take you through the traffic and stops in your desired destination. Sounds like the technology way ahead in the future, right? Well, not really. Waymo is a self-driving car company that makes taxis which do the exact same thing. So in this video, we will look at how self-driving cars works. What is an autonomous car? An autonomous car is a vehicle that is capable of sensing the environment and operate without human involvement. A human passenger is not required to take control of the vehicle at any time. An autonomous car can go anywhere a traditional car goes and do everything that an experienced human driver does. Are autonomous cars a recent invention? People have been dreaming about self-driving car almost for a century. But the first vehicle that everyone really deemed autonomous was the Stanford car. It was built in the 1961 that could navigate around obstacles using cameras. And it was like an early version of artificial intelligence in the early 70s. And this design had some limitations because they need 10 to 15 minutes to plan every 1 meter move. In recent years, many efforts have been made by manufacturers to make self-driving car a reality. You might have seen this image of Google's self-driving car. Since this is a fairly new technology, the government has not yet approved such technologies to be used by the public. Okay, but how can a self-driving car know the obstacles in front of them? Or what if a dog suddenly enters in front of your self-driving car? Before thinking about what a self-driving car could do, think about this. What would you do when a dog suddenly jumped in front of your car? Obviously, you would immediately hit the brake, right? But what if your car was self-driving? It would have super wide-angle cameras that could see the dog trying to cross the road before even you notice it. So it would just brake the car as soon as the dog jumped in front of your car, and you wouldn't have even seen the dog in front of you. That's how efficient and accurate self-driving cars are. Self-driving cars are already popular in many developed parts of the world. Now let's look at how autonomous cars drive by their own. Self-driving cars have sensors all around their chassis that helps them see the surroundings. Complex computers inside the car then process these images and guide the car to move in the correct direction. These cars also have GPS to tell the car where the destination is. Now let's have a detailed look at the parts that differs self-driving car from a traditional car. And they are camera, radar, lidar, some other sensors and computer power. The camera captures everything needed for the car to drive. Radar is one of the primary means that self-driving car utilizes to see along with lidar and computer imagery and cameras. Radar is the lowest resolution of the three, but it can see through adverse weather conditions unlike lidar, which is light-based. Radar on the other hand is radio-based wave, meaning that it can propagate through things like rain or snow. LiDAR sensors are what you will see on the top of self-driving cars spinning around. These sensors shoot out light and use the feedback to generate a high-detailed 3D map of its surrounding area. LiDAR is very high resolution compared to radar, but it has limitations in low visibility weather due to it being light-based. Other sensors. Self-driving car will also utilize traditional GPS tracking along with ultrasonic sensors and inertial sensors to gain a full picture of what the car is doing as well as what's occurring around it. Computer power. All self-driving cars and essentially all modern cars requires a computer on board to process everything happening with the vehicle in real time. Self-driving cars requires extreme processing power. So rather than traditional CPUs, they utilize graphical processing units or GPU to do their calculations. However, even the best GPU have started to prove insufficient for the needs of the extreme data processing seen in self-driving vehicles. So Tesla has introduced a Neural Network Accelerator or NNA. These NNAs have extreme processing power in real time and are capable of handling real-time image processing. For a perspective between CPU, GPUs and NNAs, this is how many giga operations per second they handle or GOPS. CPU 1.5, GPU 17, NNA 2100. NNAs are the clear winner and by many times. Okay, I'll explain it in a more simple way. Radar sensors monitors the position of nearby vehicles. Video cameras detect traffic light, read road signals, track other vehicles and look for pedestrians. LiDAR sensors emit pulse of light off the car surroundings to measure distance, track road edges and identify landmarkings. Ultrasonic sensors in the wheel detect curbs and other vehicles when parking. The computer software then processes all the sensory inputs given to the car to make further decisions. The technology on self-driving cars are improving. Elon Musk, founder of Tesla cars, has famously claimed that cameras are the only sensor technology needed for self-driving cars. This is because we just use our eyes to see the road, right? We don't use any other sensor that helps us see through objects. What we just need in an electric car is the algorithm to be able to fully understand the image they receive. Camera images capture everything needed for the car to drive. It's just that we are still developing new ways for computer to process the visual data and translate it into 3D actable data. It's just that we are still developing new ways for computer to process the visual data and translate it into 3D actionable data. Tesla have 8 external facing cameras to help them understand the world around them. Okay, so what are the benefits of autonomous cars? The main attraction of autonomous car is its potential for dramatically lowering carbon dioxide emission. By 2050, there will be a revolution in urban transportation with self-driving cars. That they reduce traffic congestion, cut transportation cost by 40%, improve walkability and quality of life, free up parking lots for other uses, reduce urban carbon dioxide emission by 80% worldwide. Also, did you know that there are 5 levels of autonomous cars? The 5 levels of driving automation indicates how capable the vehicle is of acting and reacting to its own. Level 0, that is no automation. At level 0 autonomy, the driver performs all operating tasks like steering, braking, accelerating or slowing down and so forth. Level 1, that is driver assistance. At this level, the vehicle can assist with some functions, but the driver still handles all accelerating, braking and monitoring of the surrounding environment. Level 2, partial automation. Most automakers are currently developing vehicles at this level where the vehicle can assist with steering or accelerating functions and allow the driver to disengage with some of their tasks. Level 3, conditional automation. The vehicle itself controls all monitoring of the environment using sensors like LiDAR. The driver's attention is still critical at this level but can disengage from safety-critical functions like braking and leaving it to the technology when conditions are safe. Level 4, high automation. At level 4, the vehicle is capable of steering, braking, accelerating, monitoring the vehicle and roadway as well as responsible to events, determining when to change lanes, turn and use signals. At level 4, the autonomous driving system would firstly notify the driver when the conditions are safe. Then only the driver will switch the vehicle into this mode. This can now determine between more dynamic situations like traffic jam or merging into a highway. Level 5, complete automation. This level of autonomous driving requires absolutely no human attention. There is no need of pedals, brakes or a steering wheel. This autonomous vehicle system controls all critical tasks, monitoring of the environment and identification of unique driving conditions like traffic jams. Fully autonomous cars are undergoing testings in several parts of the world but none are not yet available to the general public. We are still years away from that. The challenge ranges from technology and legislative to the environment and philosophical. So that's it for today's session. Hope this video was informative to you. As always, if you have any doubts and queries regarding this session, feel free to ask it in the comment section below. So see you all in the next session. Till then, bye bye.